Alrighty, we go to example 3. This is video number 2 of this section 2.4. We're given a graph. It is called g of x. I know that because they tell me this is g of x. We're going to find the following values. If possible, we're going to find the following values. Okay, g of negative 4. Can we figure out what g of negative 4 is? Well, where's negative 4? 1, 2, 3. Here's negative 4. What is this point? Would we say that it's 1? Could we say that it's 1? We could, mainly because I'm looking at this line. If it's at negative 6, at x equals negative 6, my y is 2. If I go 1 down, it goes 2 over. And if I go 1 down, it goes 2 over. So it does follow the slope of that line. It would have to be at 1. All right. What about the one right under it? G of negative 2. G of negative 2, that would be right here. G of negative 2 is 0. But now let's look at the one next to it. G prime of negative 2. What is the derivative value at that point? Well, if I erase my point, you'll notice that there's a sharp turn, right? The slopes coming from the left and the slopes coming from the right, excuse me, are not the same slope. Therefore, this is undefined. The derivative doesn't exist because of this sharp turn in my graph. All right, what about g prime at 2? Well, g prime of 2 means the slope of this graph of g of x at 2. Are the slopes the same coming this way and coming from the other way? Coming from the left, it's curving. Coming from the right, it's a straight line. It's not a smooth transition. Like there's still a sharpie turn, kind of like there was a sharpie turn over here. So we're going to say this is undefined as well. All right. What about the one above, g of 3? Can we figure out g of 3? Well, sure. G of 3 is just the y value at x equals 3, and that's 2. Can we figure out g prime of negative 4? What is the slope at this point? Well, we said earlier that this segment goes down 1, 2 to the right, down 1, 2 to the right. So that means this is down 1, 2 to the right. The slope of this line at x equals negative 4 is negative 1/2. What about g prime of 3? The slope at 3. Is there a slope value here? Well, no. It has to be undefined because the derivative does not exist. And then finally, g prime of 4, the derivative at 4, 1, 2, 3. Let me use this color. 1, 2, 3, 4. What is the slope at that point right there? Well, that point is on this segment, and this segment goes down 1, 2, and it goes to the right 1, 2. So that's going to be 2 down, 2 to the right. I believe that's negative 1. So from the questions that they asked, I can say with confidence that g of x is not differentiable at x equals negative 2, x equals positive 2, and x equals 3 because the derivative does not exist there. It is differentiable at x equals negative 4 and at x equals positive 4 because the derivative does exist there. Now, the derivative could exist at a bunch of other points, right? We didn't check all of them, but I'm just saying from these 8, I can make those statements as true statements. All right. Now we come to this part. I got to be careful. I am also introducing a new symbol, which we haven't seen before. That would be this one. So if h prime is the derivative of h, then h double prime is the second derivative of h. And you're saying second derivative, what the heck? Well, the second derivative is the derivative of the derivative. It's the slope of the slope. Wait, what is that? What? What? Well, that's what we're going to cover here, and this will be our second video here. All right, there's something else we need to watch out for. They give us the graph of the function h prime. So this is the graph of h prime. Remember how we always write y equals f of x or y equals h prime, or in this case, y equals h prime of x. So the y values on this graph are already the slopes of h. So I'm not looking at h, I'm looking at h prime. So if I'm looking at the graph of what they're asking me for, well, then I'm just going to look for the y values. For example, on this one, I'm looking for h prime of -1. So I go to -1 and I look at this point, but this is the point that is h prime. So therefore, my answer is just 3. Or I look at this point, h prime of 1. I go to 1. But the point is h prime, so the y is the h prime value at x equals 1, and so therefore that's just 1. I have to change I tell students, you have to change your lens, right? You're not looking at the original function, you're looking at the derivative function, so the y values are the slopes. And so if it's looking for h prime of 1, you don't actually have to look at the slope, you look at the y value because that's what this graph is telling us. What about h prime of 2? H prime of 2 would be this. Is there a y value there? No, there's a hole in the graph, so therefore there's no slope, and this is undefined. What about h prime of 4? H prime of 4 would be here, and that would be 1/2. So now let's get into f. What the heck is f? F is the derivative of the derivative of h at -5. So it's the derivative of this graph. So that means I'm looking for the slope at -5. So I come back to -5, and I'm talking about this point here, but I'm not looking at the y value. I'm looking for the slope of this point on this segment. Because I'm looking for the derivative of the derivative, I'm looking for the slope of this graph. I need to find the slope of this line. Well, this line goes down 1, 2, 3, 4 to the right. So therefore, this is -1/4. Yes, no, maybe so. What about this one? Let me change colors here. What about h double prime of 4, the second derivative of h at 4, the slope of the h prime graph at 4. So I'm looking at here. I need to find the slope at this point, the slope of this graph, because this graph is h prime, so the slope of the slope. And so I'm going to find the slope of this line segment. So this is going up 1, 2, 3, and then over to the right 2. So this is just 3/2. So I have to be careful. I understand that the derivative is a slope, but I also have to be careful with the information that I'm given. In this case, we're given the graph of h prime. So that means the y values on this graph are already the slopes. But when I'm trying to find h double prime, that means I'm looking for the slopes of this slope graph, which would be what I did with f and j, and what I'm about to do with I. H double prime at -1. At -1, I'm looking at this. What would be the slope here? Oh, the slope would equal 0. Hmm. 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 What would the slope be at -3? So h double prime of -3, I'm looking at right here. Oh, that would be this point. What is the slope here? Well, that's a sharp turn. If it's a sharp turn, then that would be undefined. If you want to try some of these and see if you catch on, um, I'll have the solutions next time. and that way you can check. You can also, oh, we did all the ones on the top, but we can check your reading of graphs using these symbols. Remember, we're talking about differentiability. Differentiability is, does the derivative exist? Sometimes people will use this phrase. You might see this phrase, twice differentiable. That means the first derivative exists and the second derivative exists. It's twice differentiable. But we'll get into that. Again, it seems like I keep referring to Unit 5. We'll get into that when we get to Unit 5.